Hello everyone, welcome back. I'm going to talk about this problem in the circular motion and gravitation. This is kind of like a good problem for the exam or in your quiz. It's good for the circular motion. It's pretty good problem and it's pretty a little bit tricky, but if you know about the how to draw a free-body diagram and about the Newton law or vector, this will be very easy. Okay, so a pendulum ball of max 250 gram is at the end of the string of length 50 centimeter. Okay, so the question is given m. So this m is 250 gram. Okay, and the length is 50 centimeter. Okay, the ball move in the cycle. If the ball move in this cycle, the string sweep out of the path. This string will be moving. You see imagine like this, the pendulum. Okay, so it's going like this is moving like this, right? That's why in this picture is the pendulum is like this, but it's going to move like this. When you release it, it's going to move like this. Okay, so the anchor theta is 35. This is very similar. The question is given, okay, with the vertical as shown, and what's the one? Determine the tension in the string. The tension, they want a tension attached to the ball. So that obviously they have a tension T right here. Okay, I'm gonna draw with this. That have a T, and then find the speed of the board. The speed is mean velocity. Okay, so I'm going to write the question. Mass is m. Hold on, let me change the pen. Sorry about that. So mass is m is 250 gram. Okay, and length L is 50 centimeter. And what we see is theta. Theta is 35. Okay, and then what they want is A is they want attention. So T is equal to question mark, and B is velocity is question mark. Okay, so before we start, we gotta look up the unit of the mass. So in the physics, we always use with the kilogram. Okay, but most of the time is you have to convert to gram to kilogram. So to change a kilogram is going to be 10 power minus 3 kilogram. Okay, now centimeter to meter is divided by 100. Okay, I'm gonna use the calculator. So this is 0.5 meter. Okay, so we're going to find for A. So before we find for A, we have to look at this. Okay, we gotta look at this line. This is the tension. Every tension line is half line is x. This x, and then it's gonna be y. So remember, always if the axis is on the x, it's always going to be cos theta. On the y, it's always to be sine theta. So what we see is, and also they have a gravitation mg right here. Okay, so what we see here for the x is t cos theta is mg, because it's same with mg. Okay, in the free body diagram. Okay, so we could find t. So t is equal to mg by cos theta. Okay, that's equation 1, not equation 1, but just put it. Now we just plug in the mass is 250 into 10 power minus 3. G is 9.8. Cos theta is 35. So if we solve this, we got 250 into 10 power 10 power minus 3 into 9.8. This is cos 35. Okay, so we got 2.990. So we say the T is approximately 2.99. Tension is Newton. Okay, so we got to find for the B. The B velocity. We already look at the x-axis. For the y-axis is t sine theta is y. In y, when we look up the y-axis, right here there's no gravity. Okay, because the gravity only have in the x-axis. There's no gravity. So what we have, they have a central pendulum force right here. Okay, it's passing through right here. It's supposed to be passing through in the middle. Okay, I drew like not really correctly. Okay, so that's why central pendulum force is F is equal to mv squared by r. So we got equal to v squared by r. So t is right here in equation 1, mg by cos theta, and this is sine theta, and mb squared by r. So what we got here is mg, so sine by cos is tangent. Okay, so this is tangent theta, and mv squared by r. So we gotta find v, right? So we use the crossing method. So mv squared equal to mg tan theta r. So v squared is equal to mg tan theta r by m. Okay, it's very easy. So we just square root of mg tan theta r by m. So right now we just plug in. Don't plug in yet everything before you get v. Okay, if you finish everything, you can plug in, or otherwise it's gonna be messed up. So right now what you can do is we can cancel out m. See, so oops, we don't need this. So we got g is 9.8, so tangent 35, r is with radius. Radius is I think I need something r. Let me check my cheat sheet. Radius So radius is on sine theta. Okay, so radius is on sine theta. On sine theta. Okay, so 9.8 tangent 35 is 0.5. And sine 35. Okay, so we're going to find 9.8 into tangent 35 into 0.5 into sine 35, which is equal to, oops, into tangent 35 into 0.5 into 5 into 0.5 into sine 35 is 1.40 meter per second square. Okay, so this will be the answer. That is perfect. This kind of like might be a little bit tricky, but I still don't know why the R is sine theta. I think maybe it's like an equation or something, but I'm not sure. I'm gonna check with the ChatGPT later. You can check it too if you want, or you can ask the professor, because I don't want to be say like, hey, my method is correct, or what I'm saying is, you gotta do with what I said. I'm not do like that. That's why it's the better or easier way is you can chat with your professor or with AI. I'm gonna try to do later. Okay, I see you in the next video. Thank you.